All right. So, yes, happy April Fool's Day. So today, we're going to talk about another sampling method called simple random.
I'm exhausted trying to visit every house in this town. I know. I'll draw a few phone numbers out of my hat and call those households to get their opinions. My first call will be to the office of the town mayor. Oh.
Okay, that's just supposed to be a really bad joke. So you want to collect a sample, right? Like the mayor. The mayor's trying to collect information about his trash issue. He has decided convenience, that wasn't really fair, systematic, all that had its issues. So he decided he's just going to randomly pick phone numbers, call those people, ask them their opinions. What would be some benefits to this, and what would be some drawbacks? So again, pros and cons. So what do you think? Longer?
Well, a benefit is that it is definitely completely random. There's no way there's going to be a bias unless the odd chance that you somehow pick like all of one.
Well, okay. So we have to be careful when we say that. There's no way there will be a bias in the group.
Yeah.
Each individual will still have their own bias.
Yeah, but like there's that small sliver of a chance that you somehow pick all the same group.
Yeah, everybody that you call agrees with each other or something like that.
Yeah. So then you don't have all the sides, but it's completely random.
So one pro that you're saying then is it gets rid of bias.
Yeah. Like completely.
So no bias, or like very, very, very little chance of bias. But we'll just go ahead and say no bias. Anyone else have other pros or cons? Well, what do you think? If I randomly choose somebody and call them, does that take long? No. So it should be easy, right? So this is an easy way to do it. I just randomly choose and I give those people. Like when we're doing prizes or something and I randomly choose. Like, here's your class, right? When you talk about putting items in a hat, does it actually mean you have to put items in a hat?
Yes.
No. So, if I take your note cards, everybody's names.
I love doing that. Looks like you're infinity balloon.
And shuffle you guys up. And so, what about each of you? When I reach in here to draw a name, what about each of you? Like, what's the chance that I draw Franny versus the chance that I draw Layla versus the chance that I draw Zach? Brennan? Everyone has the same chance. So, another pro is equal chance. Every person has an equal chance of being picked. If I did convenience, only the people convenient to me have a chance of being picked. If I chose systematic, there's a system determining everything. Everybody has an equal chance here, which is why I like simple random more than anything else. What are any cons? If you think about this situation specifically, Thomas, what do you think?
You could accidentally pick yourself.
Yeah, you could accidentally pick yourself. If you were a member of the population, so depending, like, if I'm choosing people in the class, I'm not in the population because I'm not in the class, right? So depending, you could choose yourself. So you guys can go ahead and write that down. I'm just going to try to straighten the cards. He's using phone numbers to call every person that he decides to call. He's choosing only phone numbers. So let's say he got his phone numbers from the phone book. Does every single house have a phone number necessarily? No. So
People doesn't have.
yeah, a con for this situation specifically is he could leave people out. If people don't have phone numbers, they have no chance. So the whole equal chance is if you're in the population. You only have an equal chance if you're in the population. So you have to make sure that your method of simple random sampling is an accurate method. If I choose phone numbers for the community members, that's not very accurate because not every community member has a phone number.
But everyone
You could,
has a house,
yeah,
I guess.
you could choose addresses at random, but then someone who doesn't have an address listed might get left out. Yeah, exactly.
How's your game going?
It's good. It's almost over. We have a canteen tonight, so that's real fun.
Yeah, DJ.
Yeah, I won't be able to make it. Sorry, guys. DJ Hudcap will be here filling in. All right. So simple random sampling. What is our definition of simple random sampling? What do you think? What would be a good way to define this? Well?
A random choice that you can make, but it's available to you.
Okay, so randomly choosing. Well, so that depends. Available can kind of be taken a couple different ways. I could choose somebody that's not right here available to me, like convenient, but then I could get them. So like they have to be willing or in the population. But how we like to talk about it is a sampling method where
Each member has the same chance to be chosen for the sample.
The biggest thing that we care about is equal chances. We want everyone to have the same probability. So in your notes, if you're deciding what to write, your definition could be every subject, because remember that's each person or every item, every subject has equal chance to be picked. Every subject has an equal chance to be picked. One way that we do this that can completely get rid of bias is the 3-step method right here. First thing we have to do is code. Sometimes we code by writing things on a slip of paper, and like you'll sometimes see people like fold them in half. Oh, I don't want anyone to see what it is. So that's like a way of coding. I code by just not looking at the cards and randomly mixing up, and then I take my sample, top, then the next, then the next. But when we assign numbers to members, and I actually saw this go really, really fishy. If you ever want to hear a good story of random sampling gone wrong, come talk to me about that. But what we want to do here is assign numbers to the members, so then I can use a random number generator to find my numbers. There's a website, closed.
Aren't you going to use that tonight for the lip sync contest?
Yes, I am. That's exactly what I talked to you guys about this morning, about whoever signs up for lip sync before the end of the day. I'm going to assign numbers and randomly generate them. Random.org is a great website. Cool. Like, there's lots of information on here about random events and different things. But the biggest thing that I use it for is this random number generator. You tell it the minimum number and the maximum number, so like your range of numbers, and it just randomly generates numbers. And you can just keep clicking it to keep generating numbers.
Actually, in the
There's
Mexican
one
store,
in
they
the
actually have
for it
those.
to create the same number twice.
Yeah, so here, when I assign numbers, actually we can,
Like systematic sampling,
So,
you need a list
on
of
your
all of the
paper
members in a
show
population.
that we,
Assign a unique number.
on your paper show that we assign a number to each person. You can just write it right over top of it if you want. So on my paper earlier, I just had like person 1, person 2, person 3, person 4, person 5, and just make sure that every person gets a number. And somebody tell me how many people we end up with in the group. How many people are in our population? Do not count the researcher. The researcher's not part of the population.
What's the researcher?
The person collecting the data. So if I was doing the survey, I would be the researcher. I would not choose myself to survey. Because
Because you counted the researcher. Yeah, you did.
you should get 20 if you don't count the researcher.
Next, like,
So, everyone have your people numbered?
yeah.
Now we're going to circle who we choose for the sample. We want a sample of 5 people, okay? So what do I need to do with my random number generator before I start? Change my max to 20. So, first person we generate, person 1. Circle your person 1.
Wait, what if we don't know where a person 1 is?
Well, you were supposed to assign numbers to
Yeah,
each
but
person.
I can't see my numbers.
Well, that's your problem. Next person. Person 3.
3.
I bet that's gonna be number 5.
Number 20.
Next person. Number 11. Next person is number 4. And the last person in our sample is number 6. Now, you might think, wait, we had 1, 3, 4, and 6. Those are all really close to each other, Oriana just said. So don't circle these people, but let's see what happens if I keep randomly generating numbers. What's your prediction for the next 3 numbers I generate?
9. They're gonna be
They'll be higher values, right? 20, 11, 5, 4. So, but it's random. So the problem is sometimes we get the same number again. Having a number already happen isn't going to stop it from happening again. Every new random trial is brand new. Every time I roll my die, it doesn't matter what dice roll I just had. Every time I pick it up and roll again, it's brand new. So do not think that the previous numbers have anything to do with your future numbers. It doesn't. Every random generation is random in itself. It's 100% random on its own. Does that make sense?
Yeah.
Previous value. It doesn't matter that 1, 3, 4, and 6 were close to each other. That doesn't matter. We just randomly generated those numbers. So we as humans, we like to see patterns. We like to recognize, wait, those numbers are close. It doesn't matter. Here, it doesn't matter. So, let's see if these are random. Mr. Torres.
What?
Torres.
Torres. Sorry.
Actually, title 4.
It'd be so much cooler if I spelled it with a Z.
Terminal.
We, what do we, we have a lady at our church, because we were at, my grandma's funeral. We have a lady who says yins. You ever heard anyone say yins?
I have.
Like
When I went
y'all,
to
or,
Pennsylvania,
yeah,
I
it's a
rented 3
Pennsylvania
guys.
thing.
They were just like a yins.
So we were trying to figure out how would you spell yins, and we
It's
decided
Y-
it has to be spelled with a Z.
I think it's Y-I-N-Z.
We decided either Y-I-N-Z or Y-U-N-Z, like, because she says, like, U-Ns, like, combines U and... Okay, so Luke, you make an alphabetical list of students,
Alpha.
and you select the first 10 names on that list. Is that sample a simple random?
Do we have the I have a question. It kind of relates to the alphabet. Do we have the alpha, beta, gamma, delta because of the alpha? Because alpha.
That's the Greek alphabet.
Oh.
No, it's the Greek alphabet.
Alphabet.
Is from the Greek
Yeah,
alphabet, which is alpha beta.
yeah.
Never mind. I thought it was.
Don't think too hard. You might hurt yourself. What's up? In your top drawer there. So, if we ever want to get to Mind Trap, we got to get moving. Luke, if you select the first 10 people, is that simple random? No, what is it? Convenience, right? So on your paper, you're going to put no, this is convenience. It should be in this top drawer, like this. What about Layla? If you mix all the students' names in a hat, and a hat is really just any object that you can put names into, and select 10 names while blindfolded, is that simple random? Yeah, because you mixed everybody up, you randomized them, and you selected them blindfolded. Hey, Divine, can I get some focus?
Oh, sorry.
So that is simple random because you mixed them and you chose them while blindfolded. Because if I mix the names up and then I choose them while looking in it, that's not random. That's why sometimes people say, here, pick something. They'll put it above your head. They're like, here, choose something, because then you can't see. You're picking at random.
But
So
what if you have extra vision?
yes, thanks,
You don't
Brennan. So you assign,
You see on your head.
Zach,
On top of your head.
you assign a number.
Whoa.
Zach, sorry for the delay. You assign a number starting from 1 to each student in your class. Then you pick 10 of these numbers at random using something like random.org. Yeah, because you assigned numbers that randomized everyone's identity, and then you picked the numbers at random. So that is simple random also. Yeah, one letter can change that statement a whole lot.
What?
You said nice as lice.
Nice as rice.
Oh,
Yeah, but
Wait,
one
nice
letter
as
could.
lice? Oh, I get
Nice
it.
is lice, yeah.
All right, try this on your own. Here's what I want.
Yeah,
Here's what I want. If it's simple random, actually we'll do this together because it's kind of weird because it's flowers in a field. So we're researching how many pink flowers are in this field of red flowers. So sometimes flowers like breed together, sometimes you just get a weird seed here and there. So could I assign a number to every single flower and do the simple random technique like we talked about?
Yeah.
No, because most flowers look identical.
Okay, well, so hypothetically,
Yes.
I could assign a number to every single flower. I could tag them, and then I could use a number generator. We would not do that. That would not make any sense.
I'm not.
And it would take forever.
Oh my god.
So, Franny, if I choose every 10th flower in the field, starting with the third one, is that simple random?
No, that's systematic.
Ooh, no, this is systematic. Ethan, what if I choose 3 flowers from the field?
Yeah, it's technically. I mean, they didn't say randomly. Yeah.
So, here's the problem. They don't tell me how I chose them.
Yeah, so
And
technically yes, but no.
would 3 flowers be a good sample?
No, not at all.
So, not only do I not have enough info, but this is not a good sample. So you could either write not a good sample or not enough info. I don't know how they chose the flowers. I don't know if they chose them all, like reached down and picked 3 right beside each other, because that would completely have a bias. That would be a convenient sample. So they don't tell me how we did it. I'm assuming they reached down and picked 3 flowers. You choose 3 flowers from the field. So you could say no, or you could say not enough info, or you could say not a good sample. Cassidy, if I choose 50 flowers closest to me. Yeah, this is convenience. My E's sometimes look like C's, by the way. You guys have probably figured that out, but my loop doesn't always show as open. Mine's a smartboard issue. Yours is a handwriting issue.
Mine's handwriting.
Yeah.
Alright, whatever.
I mean, I have the same issue while handwriting, but up here it's a smartboard issue. And Karina, if I choose 50 flowers from different locations in the field. So ask yourself these questions. Will 50 flowers be a good sample? Like bigger, yeah. By going to different locations in the field, should I get a random sample of flowers? Yeah, so this is as close to a random sample as we can get since we're in a field of flowers. It's kind of a weird situation to think about. I will normally give you easier, like, people or items that are physical. You know, there's a limit, a quantity. We know the population. A field of flowers is kind of a hard population to work with. I'm going to be nice and just ask that you write a couple of these on your paper for similarities and differences. So when you think about simple random and systematic, can anyone think of any similarities or differences? Yeah.
They both have they both are completely random or mostly random.
Yeah, they both get a random sample, right?
Yeah.
They both don't have bias.
They both should not have bias. But remember we talked about systematic yesterday? If the population has a pattern, there might be bias in my sample. So it will hopefully not have bias, but it could. Luke?
Both types of samples.
Yeah, they both produce a sample. Is what you mean is they produce a sample? So here's some similarities and differences. What you notice here, systematic and simple random are very similar to each other. The only difference is systematic, I have a rule telling me who to pick. Random, I'm just picking people randomly. Or things randomly. question?
I think you should need coffee.
I had none this morning. That's my issue.
Oh,
Did you take
yeah,
a coffee
this
this
morning?
morning?
That's really
Yeah,
hard.
well, got it figured out. We're gonna skip to. Actually, I'm just gonna come back to your notes. We're gonna skip the stars right here. We're gonna skip the stars. We're gonna go to penguins.
Oh, yeah.
So we're studying some cute little penguins,
But they smell.
and that's what the first class said too.
I love the name Miko.
We choose. We choose 7 penguins. 1, 2, 3, 4, 5, 6, 7. What we're researching is how many of our penguins are between 30 and 40 pounds. So what we first need to find is how many of my sample are between 30 and 40 pounds, and then use that, and I remember what that word was, where we can take information from my sample and use that to determine information about my population. Started with an I, it was a big word. If you if you do this, you are taking information you know to predict. It's an inference. We're going to use this to infer. Big enough.
It's 2 syllables. It's 3 syllables.
So we go through and identify everything that matches what I'm looking for. So between 30 and 40 pounds, gravity works. 28 pounds, does that count? No. 35?
Yeah.
Circle it. 42?
No.
24?
Yes. No.
No, that's not between 30 and 40. 31?
Yes.
39?
Yes.
34? So how many were in that range that I was looking for?
4 out of 7.
4 out of 7. This is my blank of blank. We used it, you know it, Thomas?
My
Blank of blank. These are kind of big words.
Sample of our population.
No.
No? Okay.
Is it a C? Is it 2 C words?
A C word and a P word.
Oh! This population.
I know.
Granny? It's our constant of proportionality. I don't have lots of space, but if you could not think of that, you should probably write the whole thing out. Constant of proportionality.
When you said it was a C word and a P word, I was like, yeah, it's constant
Yeah, CP.
proportionality.
So to make my estimate, because we cannot say this definitively, but this is going to be an estimate that is very close. So to find my estimate, I take my constant of proportionality and I multiply it by the population. We're going to take your constant of proportionality and multiply it by the population. So 4/7 times 35. I make this a fraction. Then I can actually cross reduce here. My 7 and my 35 can both be divided by 7.
1 and 5.
Yep. So 4 times 5.
20.
So I have an estimate of 20 penguins are 30 to 40 pounds in the population.
I like the name Miko.
I heard you the first 3 times.
I
It is a cool name. My mother-in-law's dog is named Nico, like with an N.
have you heard Mrs. Pettigrew's cousin's or nephew's name?
No.
It's Dante.
Oh yeah.
Le Bourgeois.
Dante Augustus Labourgeois. That's like Mrs. Pettigrew's like cousin's name or something, or cousin's kid's name. Yeah. It's like the sweetest name ever. So I want you guys to apply the exact same math, the exact same technique with the got it. You're looking for stars with a brightness magnitude between 0.5 and 1. Their brightness magnitude between 0.5 and 1. Mm-hmm. Use it to make your estimate out of the 50. The 50 brightest stars, that's your population. So your population is the 50 brightest stars. You might recognize some of these. Hatter, Rieger, Sirius. That's where Sirius Radio stole its name. Sirius is a star.
Like Sirius Black?
Because that was the population size. We're told the population. That's why down here we're told the population is 50. It's the constant proportionality times your population size. The first thing you have to do is find your constant proportionality by finding the part over whole. So how many stars are in these notes? You don't need, they just passed out accidentally. So how many stars are in that magnitude? 2. So it's 2 out of 9. So we take that and multiply it by your population size, which is 50.
Mr. Hudson?
Yeah.
I'm guessing.
Yep, you're good.
I have a question.
Yeah.
I want to make sure that did I do it right? 7 for 9. Why did I say 7? I meant 9.
So what I see most of us have,
I meant 9.
Altair and Hatter.
Done.
Hater.
No, I thought that's Hatter.
Sure, I don't know. I make these things up. So, most of you found that your CP was
11. Basically 11.
2
Oh, yeah.
ninths.
I'm sorry.
Then,
Yeah. That was
2 ninths times what?
50.
50 over 1, which becomes 100 over...
And I got 99.
So it's 11.1 forever.
But that's
11 and 1.
It approximates to 11 stars.
That's a lot of stars.
But that's just would have that magnitude brightness. So some might be lower, some might be higher. Just 11 stars fit there. Any other questions about simple random sampling?